A very good morning to all my dear students. During this COVID-19 pandemic period, are you getting bored sitting idly at home, unable to go to your school, meet your dear friends and teachers? I know all of you are very sad in that. But I know most of my students are very active. They might be actively participating in some or the other work during this lockdown period. Some of my students will be actively participating in some games. They might be doing some gardening work. They might be actively doing some painting work. They might be actively doing some artwork. I know most of my students are very active. But I also know that some of my students, a few of my students are very lazy. They are like that in my class also. They don't do any homeworks. They don't do any assignments. They will sit idly. I know some of you are like that. I know some of you are idly sitting and watching TV. I know some of you are idly playing with the mobile games. I know some people are there who spend most of their time eating. I know there are some of my students like that. Do you know them? Yes, I know their names also. Should I call them? No. Okay, in the periodic table also, there are some elements like them. Can you name them? They are very lazy, they are very inert, they are not active, they don't participate in any chemical reaction. There are some elements like that. Do you know their name? Okay, in the periodic table, the elements are classified in groups and periods. And the 18th group of the periodic table are called, they are having a name. What is that? Yes, they are called inert gases. Why they are called inert gases? They are called inert because they are just like some of my students. They are very lazy, they are very inert, they don't participate in any chemical reaction. They just stay themselves. They don't go and mingle with other atoms. They don't go and talk with other atoms. They will stay as themselves. They are very lazy people. They have another name also. Do you know that? This group 18 elements have another name also. Can you guess that? Yes, they are also called noble gases. Why are these lazy people called noble? Yes, there is a story behind this, right? Before the Renaissance period, that is during the conventional period, there were some people called noble people, and they mostly belonged to the European countries. These noble people belonged to the higher strata of the society. They belonged to the higher standards. They had so many servants. They don't usually do any work. They will sit idly and order the servants to do all the work. They will sit idly and eat. They will just sit idly and enjoy their work. They are very stable. They are very inert. They are very lazy also. There are such people like that, and they were called noble people. Likewise, in our periodic table also, these group 18 elements are very lazy, very inert. They are not at all active. They don't go and associate with anyone. They will stay with themselves only. They don't even go and talk to other atoms. They are like that. And hence, they possess all the characteristics of this old generation noble people. So, they are also called noble gases. So, what did we learn now? We learned that the group 18 elements are called inert gases because they are very lazy, they are not at all active, they don't participate in any chemical reaction, they don't go and associate with any atoms, they don't even go and talk to any other atoms. Like What? Like our noble people. Hence they are also called noble gases. Right? Can you name some of the group 18 elements? Yes, I know you have studied about them. Yes, you are very true. They are helium, neon, argon, krypton, xenon and radon. Do you get now? Yes, these people are called group 18 elements or noble gases or inert gases. Can you name once more? Helium, neon, argon, krypton, xenon and radon. Do you know their atomic number? Do you know how to write electronic configuration? Yes, you have studied in your previous class. Now let's write the electronic configuration of group 18 elements. Okay. I'm going to write the electronic configuration of group 18 elements. Okay. Here I am writing the atomic number. Next I will be writing the electronic configuration. Electronic configuration will be written here. Okay. Can we start? Okay. The first one is helium. Its atomic number is 2. So its electronic configuration will be 2 itself. Right? You know about how to write. How many shells are there in the board's atomic structure? The shells are represented by letters K, L, M, N, etc. Right? So the 2 electrons will belong to the K shell here. Okay, I know you know about how to write the electronic configuration. Next is neon. Do you know its atomic number? It's 10. So how to write the electronic configuration according to this order? Yes, we will write it as 2, 8. Next is argon. Okay, its atomic number is 18 and its electronic configuration will be 2, 8, 8. Do you get that? Okay. Next is krypton. Its atomic number is 36. How to write the electronic configuration? We will write it as 2, 8, 18. So how much is this? 2 plus 8 is 10. 10 plus 18 is 28. 28 plus 8 is 36. So we wrote it as like this. Next is xenon. Its atomic number is 54. So how to write the electronic configuration? We will write it as 2, 8, 18, 18, 8. Right? Do you have any doubt in this? If you have any doubt in this, you should go to your previous class textbooks and just refer how to write electronic configuration according to Bohr's atomic structure. You will get it there. Next is radon. Its atomic number is 86. So its electronic configuration will be 2, 8, 18, 18, 18 and 8. Do you get that? So, except helium, now you have to observe the elements from neon to radon. And you have to look the electronic configuration and come to a generalization. What is peculiar, what is similar in the electronic configuration of elements from neon to radon? You have to find the similarity in their electronic configuration. Can you identify it? Yes, it is easy, no? You can find that in the outermost shell of neon, there is 8 electrons. In the outermost shell of argon, there is 8 electrons. And in the outermost shell of krypton, there is 8 electrons. Similarly, in the outermost shell of xenon, there is 8 electrons. And in the outermost shell of radon, there is 8 electrons. Okay, so now you got a fact that from neon, argon, krypton, xenon and radon have 8 electrons in the outermost shell. And in the previous lecture, I have said that these noble gases are very lazy. They are very inert and they don't participate in any chemical reaction. They will stay as themselves. Can you associate it with their electronic configuration? Why do they don't react? Why don't they go and associate with other atoms? Is there any speciality about having 8 electrons in the outermost shell? I guess you might have studied this in your Bohr's atomic structure. When an atom is having 8 electrons in the outermost shell, that atom is very stable. That atom is said to be having a stable electronic configuration. I will say once more. The electronic configuration in which the outermost shell is having 8 electrons are called octet electronic configuration. So, what is octet electronic configuration? The electronic configuration in which the outermost shell is having 8 electrons is called octet electronic configuration. So, neon, argon, krypton, xenon and radon have octet electronic configuration. What they have? They have octet. They have octet electronic configuration. Because of this, and we have studied that this octet electronic configuration is highly stable. Since octet electronic configuration are highly stable, elements like helium, neon, argon, krypton, xenon and radon are very stable. Those elements who have an octet electronic configuration will be very stable. Hence, they don't participate in any chemical reaction. They remain as itself. They are very inert. They are very lazy. Hence, they are called inert gases. Now, coming to helium. How many shells do helium have? We have studied that helium, if this is a nucleus of helium, it is having only one shell. Which is that shell? It is the K shell. How many electrons? What is the maximum number of electrons that can be accommodated in the K shell? Yes, it is 2 electrons. 2 electrons can be accommodated in the K shell. So, since helium's atomic number is 2, it is having 2 electrons. And these 2 electrons is accommodated in the K shell itself. Since it does not have any other shells, this electronic configuration is a stable electronic configuration for helium. Like octet. Octet, we said it as octet because it is having 8 electrons in the outermost shell. So can you give a name for this? Like octet, can you give a name for this? Yes, it is called as doublet. So this is having, helium is having a doublet electronic configuration. Because of this, it is very stable since helium is having only one shell. Now can you identify why, or can you understand why the group 18 elements are very lazy? Why group 18 elements are very inert? Why group 18 elements don't participate in any chemical reaction? Now can you say that? You have to say from their electronic configuration. Since group 18 elements have a stable electronic configuration, that is, it might be octet or doublet, they are very stable. Since group 18 elements are having a stable electronic configuration, they are said to be very stable. They are said to be very inert. They don't participate in any chemical reaction. They don't go and associate with other atoms. They don't go and form any bond with other atoms. So what is a chemical bond? We can discuss what is a chemical bond and what is a chemical reaction in our next class. Okay, so far we learned about group 18 elements. The group 18 elements are called noble gases. They are called inert gases because they are very lazy, because they are very inert. They are not at all active. Why? What is the reason for that? Because the group 18 element have a stable electronic configuration. They have an octet electronic configuration or doublet electronic configuration which are very stable. Hence, they don't participate or they don't associate with other atoms. So, what about the other atoms in the periodic table? Here I have written about only group 18. From group 1 to 17, we have so many other elements. So, what about them? Are they lazy people? Are they like them? Are they like group 18? No. Why? Because they are not having an octet electronic configuration. We can see more about this in our next class. Thank you so much for listening.